Well, in this video, we're going to put the whole thing together. We are going to be given an equation where we want to find the inverse of that equation. We're then going to go through and graph both the function and its inverse on the same coordinate system, and we will find the domain and range for both of those functions. So let's get started. Here I have the function x squared minus 1, but I only want to look at the portion of the graph that is positive or greater than or equal to 0. And real quickly, the reason for that is because remember, if we started out with just the function x squared, this function itself does not pass the horizontal line test. However, I can restrict the portion of the graph that I want to look at by getting rid of values that in this case are less than 0. So if I have x values less than 0, then I'm just going to ignore them and erase it. And if I only look at this portion of the graph, you can see that that would then pass the horizontal line test. So that's what a restriction does for us on a function that may not start out to be one-to-one. So let's find then what is the inverse of this function. We know that we're going to take it out of its function notation and rewrite it as x squared minus 1. From here we can just switch the x's and the y's. So this is x equals y squared minus 1. Trying to solve for y or get y by itself, I'm going to add 1 to the left hand side. X plus 1 is equal to y squared. And now I'm going to take the square root of both sides. When I do that, I get y is equal to plus or minus the square root of x plus 1. Now I put plus or minus in here for a very particular reason. The function, the original function, had a restriction where I was only looking at a certain value, right? Positive values. So when I'm trying to determine, well, which of these positive or negative square root of x plus 1s do I need to take, we're going to take the positive one because of this restriction that I had on the original function. That's why my f inverse is just the square root of x plus 1 because of the restriction on the original function. So here is my inverse function. Now let's go in and let's graph both f and f inverse on the same coordinate system. So remember that f of x was x squared minus 1 for x greater than or equal to 0, and f inverse of x is just the square root of x plus 1. So looking at the f of x function, we have I'm going to use transformations to just, or translations to move the function around. So I have a quadratic function that is shifted down by 1, and I only want the positive x values. So my original function is going to start here, and I've got a lot of things popping up. It's going to start here at 0, 0, and it's going to shift down by 1. I have another point directly to the left, or directly to the right and up 1, and then I have another point 2 over and up 4, giving me this value up here. I know all of those points because I remember the parent function for this, and I'm only interested in this positive x value, or the values for x that are greater than 0, so I only draw this portion of the graph. It's kind of crooked, but there you go. Now, how do I draw the inverse function, the square root of x plus 1? Well, that's a square root function that's been shifted to the left by 1. So my square root function is going to start here at the origin, but I shift it to the left by 1. I know I have another point up here at 1 away, right? Up 1 over 1. And then I know, because I know my parent function, that I would have another point that eventually would be down here at 2, 3. So this is the inverse function. And you can look at this and you can see that these two graphs really do follow that imaginary slanted line y is equal to x there. So I have both the function, or the function which is in blue, and the inverse function over here in red. So how do I write their domains and ranges of these two functions? We're going to start with the original function f of x. So the domain of this function, okay, only x values. I'm only looking at possible x values. The domain of this function would be from 0 all the way to infinity. Oops, go back. This would be from, so the domain would be from 0 to infinity. And what are the range, what's the range then? What are the possible y values? Well, if you're looking at this, the smallest y value is down here at -1, and it can go off into positive infinity. So I have a -1, positive infinity. What about the inverse function? The inverse function, looking at the graph, we can see that the possible x values for the inverse function start over here at -1. That's the smallest x value that I'm allowed. Sorry, let's go back, 2.7. Okay, so we have the smallest x value at -1 to infinity. And the range, right, the smallest y value would be from 0 off to infinity. A square root function grows rather slowly, but that's what it is. So I have then the domain and range for both the function and its inverse. And notice that the domain of the function is the range of the inverse, and the domain of the inverse is the range of the function, which is exactly what we said at the very beginning of all of these videos when we talked about characteristics of an inverse function.